Hello everyone and welcome to my channel Chemistry by Miss Nidhi Banga. Today we will be talking about competency based questions from the chapter Carbon and its compounds. So let's get started. So our first question is that on undergoing complete combustion in adequate supply of oxygen, an organic compound produces only carbon dioxide and water vapor. So only carbon dioxide and water vapor as products. Based on this information, which of the following could the compound belong to? Could it be alkane, alcohol, aldehydes, or what? So, if our products just have carbon dioxide and hydrogen, that means in our reactants there should be compounds with carbon, hydrogen, and oxygen only, right? So let's see. Alkanes have carbon and hydrogen, okay, but it's being combusted or it's being burnt in oxygen. So there's oxygen as well, right? And nothing else, just carbon and hydrogen in alkane and oxygen. So it could be the compound which is being burnt, okay? Alcohols have just carbon, hydrogen and oxygen only. Even aldehydes have just carbon, hydrogen and oxygen. So all three of them can produce only carbon dioxide and water upon complete combustion. So our answer is PQR, all three of them. Okay, let's move on. Alright, so a compound with which of the following functional group is most likely to cause decomposition of baking soda to produce carbon dioxide? Baking soda is NaHCO3. That means sodium hydrogen carbonate. And we know that metal carbonates or metal hydrogen carbonates upon reaction with acids produce carbon dioxide, water and salt, right? So which among these is an acid? This is an alcohol, this is aldehyde, this is ketone and this is the acid. So clearly the answer is S. Moving on. 1 mole of ethine and 1 mole of ethene separately made to undergo addition reaction to form saturated compound. Which of the following would be different for the two reactions? Let's write the reaction. This is your ethene. They will combine with hydrogen, undergo addition reaction and will form ethane. Right. Let us see if the reaction is balanced. 2 carbon this side, 2 carbon this side. 2 plus 2 plus 2, 6 hydrogen this side and 6 hydrogen this side. So this is balanced. Let's now make ethine react with hydrogen to produce the corresponding saturated hydrocarbon, that is ethane again, right? Now let's see if the reaction is balanced. 2 carbon this side, 2 carbon this side, 4 hydrogen on the reactant side and 6 on the product side. So what we can do to balance it? We can put a 2 here. Okay, now this is balanced. So let's see what is different. The number of moles of saturated compound formed, that means the number of moles of ethane formed? No. 1 mole of ethane formed for both, right? So it's same. So that is not the answer. The number of moles of hydrogen consumed, that is actually different. For ethine, it's twice the number of hydrogen, twice the number of mole of hydrogen consumed as that in ethene. So definitely only Q. That would be your answer. Moving on to the next question. This is an assertion reason. So, assertion, vegetable oils are healthier than animal fats. True. Vegetable oils generally have long unsaturated carbon chains while animal fats have saturated carbon chains. That is also true. Okay. And is that the correct explanation of the assertion? It is actually. Okay. Vegetable oils being unsaturated, they are more healthier than animal fats. Okay, so first is your answer. Moving on. Then we have this question, short answer question. Alkanes are saturated compounds having formula this CnH2n plus 2. An example is ethane. Okay. Maya has a compound which has formula C3H4. Now would that be a saturated compound? If we put 3 in this formula, we would get C3H8. Now C3H8 would be saturated. So this is definitely unsaturated. Okay, so what is true about the type of flame this compound will give? Since this is unsaturated, this will give a sooty flame. What is a sooty flame and why would unsaturated compound give sooty flame? Unsaturated compounds have, let's compare saturated and unsaturated for 1 second. C3H8 saturated, C3H4 unsaturated. So here you can see that in the unsaturated compound there is fewer hydrogen atoms. That means there is low percentage of hydrogen as compared to here, saturated ones. So if it has low percentage of hydrogen, that means it has high percentage of carbon. High percentage of carbon means some of it would remain unburnt. Okay, some of the carbon would remain unburnt. Unburnt means it would not turn into carbon dioxide, because that is what burning or combustion means here, right? So it would remain unburnt, that means it would remain as just carbon, and unburnt carbon is soot. So saturated compounds do not produce soot because they have comparatively lower percentage of carbon. Therefore, all of it actually gets combusted. All of it gets burnt or converted to carbon dioxide. So I think that answers our first question. It would, since this is unsaturated, it will produce sooty flame. Draw all the possible straight chain structures of this compound. Let's see. So we have C3H4. So one of them would be clearly alkyne or propyne, because this formula fits CnH2n minus 2, which is the formula for alkyne. So 1, 2, 3, place a triple bond here, right? And then just saturate it with hydrogen. There will be 1 hydrogen here and 3 hydrogens here. None here because valency of carbon is already completed, right? So this is definitely one structure. But can there be another structure? Let's see. This is definitely unsaturated, so it has to have a minimum of double bond. So now if we try to saturate this compound, we can put 2 hydrogens here. Excuse me. And 1 here and then 2 here, but that would increase the number of 3. That would increase the number of hydrogens. We can have only 4 hydrogens. So how about we put another double bond here. Now let's see. Central carbon won't get any hydrogen because it has already made 4 bonds. Only 2 hydrogens can be added here. Okay, so this actually fits the formula C3H4. Okay, so this is your second isomer. Can it have any other structure? It can't. You can try, but with unsaturation, only these 2 structures would be possible. Moving on. Bromine is a reddish solution of bromine water. When shaken with unsaturated compounds, bromine actually gets added, and therefore the color of the bromine water disappears, right? Because it gets consumed up. Now, Kohli has 3 test tubes in which there is hexane, hexene and hexine. He doesn't know which test tube contains what, but let's say this is the situation, right? Which of the 3 compounds he can identify using bromine water? So if bromine water is added to unsaturated compound, the color would disappear. So if you would put this in the first test tube, the color would not disappear because it is saturated. So therefore it cannot undergo addition reaction, right? So bromine water's color would persist here. Okay, so he would know that this is saturated. If it's saturated, the only possibility is hexane. So he can actually identify this compound. Let's see what about the others. He would put bromine drops here, bromine water drops here and here. In both cases, because both of them are unsaturated, the color of bromine water would get discharged. Alright, so he would note that these two are unsaturated, but which one is hexene and which one is hexane, he would not be able to conclude using just bromine water. So which compound he could identify? He could identify only hexane. Okay, moving on. A carbon compound with formula C5H10O contains a ketone functional group. Draw the structures of the three isomers of this compound having a ketone functional group. Now, please know that ketone has a functional group isomer as aldehyde. That means basically what I mean to say is aldehydes and ketones are functional group isomers. So any ketone will have a corresponding aldehyde which would have the same chemical formula but obviously different structure. But here they have asked about isomers having only ketone group. So let's see. Ketone we know is not a terminal functional group. That means the ketone group, this C double bond O group, has to be between two carbons at least, right? So now let's try and make this structure. 5 carbon, saturate with hydrogen. Okay, that is one compound. Now if I place this C double bond O in the central carbon, let's see if we get a different compound. Okay, so this is a different compound, still ketone. Now if I put it on here, this carbon, it would be same as the first structure. Okay, so that we cannot do. But what else can we do? Can we play around with the side chains? Let's see. If I place the carbonyl carbon or the carbon double bond O group on the second carbon here, and then if I put a branch on the third carbon, it would still give me a different compound, different structure, but same chemical formula, right? So these are the three isomers that you can have with this molecular formula. If you are having trouble with isomers, there's a video on my channel, all you need to know about isomers. Do watch it. Okay, moving on. Ethanol is heated with alkaline potassium permanganate to give a compound X. How many carbon will the compound X contain? So alcohol is treated with oxidizing agent. When alcohol is treated with oxidizing agent, it gets converted into acid. And the two compounds are different only with respect to number of oxygens, because this is oxidation, right? Number of carbon would remain same. So our first question is answered. How many carbon atoms would compound X contain? The same number of carbon atom as were present in the ethanol, right? So it would also have 2 carbon atoms. Moving on, compound X is now reacted with ethanol in presence of acid catalyst to give compound Y. Okay, so when acid is reacted with alcohol, what do you get? See, this is your acid. Alcohol you write in this way, in the flipped way, right? Now just remove water. You can remove OH from here and H from here, or OH from the alcohol and H from the acid. Doesn't matter. You would get the same result. just remove water and write the whole compound as it is. CH3 C double bond O, and then you have an O, and then you have CH2 and CH3. This is the ester we get when we combine acid and alcohol in presence of acid. This type of compound, ester, so ester is the answer for this. State one characteristic property of the type of the compound of the type of Y. So Y is ester, and esters are, they have fruity smell, or you can say they have pleasant smell, right? Or they have sweet smell. Okay, one use, since it has sweet smell or fruity smell or pleasant smell, it can be used in perfumes or even flavoring agents. Okay, moving on. Compounds with identical molecular formula but different structures are called as structural isomers. In case of saturated hydrocarbon, what is the minimum number of carbon atom needs to be in a molecule for it to have a structural isomer? Okay, so one carbon, obviously it cannot have any other arrangement. Two carbons can only be like arranged in straight chain. Three carbons also, there is no other possibility. Even if you say that they can be arranged like this is nothing but the bent shape of the straight chain version, not really different. Okay, but with four carbons, what do we have? With four carbons, this is one isomer. Then we can actually have a branch point. Here, this is a branch, right? So let's now saturate it with hydrogen. CH3 here, CH2, CH2, CH3. In the second, CH3. Since three bonds are already made, we can place only one hydrogen here. Then CH3, then CH3. Okay, so the minimum number of carbon atoms for it to have structural isomer is 4. Structural isomers of saturated hydrocarbon, that is this, has already been made. Okay, all right. Okay, next question. An open chain hydrocarbon X having the formula CnH2n-2 is hydrogenated in presence of catalyst. So this X, CnH2n-2, if you remember, we have done a question like this. It was C3H4 in that question. It fits this formula, and this structure had two isomers, one with a triple bond and the other one with two double bonds, right? So this formula can have actually a triple bond or two double bonds. State the number of moles of hydrogen required to completely saturate 1 mole of compound X. As we saw in that question also, it would require 2 moles of hydrogen to completely saturate. This or this would require 2 moles of hydrogens, right, to form an alkane. Okay. The hydrocarbon X contains carbon-carbon single bond. Apart from single bonds, state the number and type of other carbon-carbon bonds that could possibly be present here. Okay, so let's say you have carbon-carbon single bond, and we just saw that it can have carbon-carbon double bond also. It can have carbon-carbon triple bond also. Okay, so apart from carbon-carbon single bond, it can have either carbon-carbon double bond, 2 of them, or carbon-carbon triple bond. All right, moving on. Shown below are structural formula of 4 carbon compounds. 2 of these compounds are more likely to have similar chemical properties. Identify these 2 compounds and give a reason for your answer. So, let's identify all compounds. P is ketone, Q is alcohol, R is carboxylic acid, and S is alcohol again. So, Q and S are alcohols. So they are more likely to have similar chemical properties because they have the same functional group. And functional group determines the properties. Functional group. Okay. Identify which of these compounds are likely to have the same boiling point. Same boiling point. Actually, none of them. Why? Because all of them have different formulas. Like none of them are identical. To have the same boiling point, two compounds need to be identical. Because even if there is a slight change in structure, it would have an impact on the boiling point or melting point. Right? Even two isomers of the same compound, even two structural isomers, would not have the same boiling point. The boiling point would differ slightly at least. Okay, and then in the homologous series, we know that as the number of carbon atom increases, there is a change, a slow change or a gradation in physical properties such as boiling point and melting point. So basically we know that two compounds will have same boiling point only when they are identical, right? And none of them are identical. So none of them would have same boiling point. Moving on. Heating an alcohol with concentrated sulfuric acid results in dehydration of alcohol, okay, to give an alkene, shown by the reaction. Pramila heated 2-butanol with concentrated sulfuric acid. Write the structural formula of all possible products. Okay, so we know that when dehydration takes place, OH from the carbon containing OH and hydrogen from the adjacent carbon goes. Now here in 2-butanol, there are two adjacent carbons to the carbon carrying OH group. Okay, let's number them 1, 2, 3, 4. So if OH from here and H from the second carbon goes, you would get CH3, CH double bond, CH, then CH3. But if, let's change the color, if the OH from the third carbon and H from the fourth carbon goes, then you would get CH3, CH2, CH double bond CH2. There is no other possibility, right? Because OH from the third carbon has to go, and then one hydrogen from the adjacent carbons, which is either 2 or 4. So these are your two possible products. Okay, moving on. Ethyl propanoate is a colorless compound with pineapple-like smell. It is present naturally in some fruits like kiwis and strawberries. So this is the structure of ethyl propanoate. If you can identify, this is an ester. Write the name of the carboxylic acid and alcohol from which this compound is formed. Ester is formed from carboxylic acid and alcohol. And it's very easy to identify which carboxylic acid and which alcohol. How? Basically, you have to break this bond. This is called as ester bond. You have to break this bond. And then these are the two compounds you would get. What is missing? See, the first part has C double bond O. So this part definitely came from the acid, right? Because C double bond O is present in the acid. So CH3, CH2, C double bond O, OH is the acid, carboxylic acid. Okay. Second part, this has only an O. Okay. So it definitely came from the alcohol. Alcohol. So this is your alcohol, from which actually combined with the carboxylic acid to give this particular ester. Okay. Now names. This is, since 3 carbon acid, we would call it propanoic acid. and the alcohol, since it has only 2 carbon, it becomes ethanol. Okay, apart from mixing the carboxylic acid and alcohol, what else should be done to form this compound? So what is the necessary condition for ester formation? It has to have concentrated sulfuric acid, okay, and you also would need to heat the mixture. Okay, so these are the 2 necessary conditions to bring about this chemical change. Moving on. An alkane has 11 carbon atoms arranged in this structure. What is the molecular formula? Okay, so we are already given that this structure has only carbon-carbon single bonds. Now, the mistakes that students are likely to make here is that they might just count the number of carbon atoms and then plug it in the formula of alkane, seeing that there is only carbon-carbon single bond. But no, these are cyclic structures, and cyclic structures do not have the same formula as straight chain alkanes. Okay, so the safest thing to do here is to just add the number of hydrogens, saturate it with the number of hydrogens. So let's start from this carbon. This carbon has 2 bonds already, so you add 2 more hydrogens. Same way here, same way here. Let's just keep on doing this. But this carbon has 3 bonds already, so it would get only 1 hydrogen. Same with this carbon. Next carbon, 2 bonds only, so 2 more hydrogens. Same here. We will keep on doing this. Okay. Now just calculate count the number of carbon and hydrogen. So we have 11 carbon here, and if you count the number of hydrogens, we have 20 of them. Now let's see how it is different from normal alkane. Normal alkane has the general formula this. So if you plug 11 in this formula, you would get C11H24. See, this is a different formula because this is the formula for straight chain alkanes. And this is not straight chain, right? Okay, moving on. Mansi wrote number of 4 compounds as the first members of their respective homologous series: methanol, methanol, methanone, and methanoic acid. Which name she has written incorrectly? Justify your answer. So methanol is present, methanol is present, even methanoic acid is present. But methanone, which is a ketone, is not possible. Why? Because ketones are not terminal functional group. That means this functional group has to be placed between at least 2 carbons. So that means a minimum number of carbon that you require to form a ketone is 3. So methanone, which suggests that it has only 1 carbon, is definitely wrong. What name she should have written instead? She should instead have written propanone. Propanone. Because it has to have a minimum of 3 carbon, which would be the first member of its homologous series. Moving on. Organic compound belonging to different homologous series can be isomers. Propanol and propanone are isomers. Can alkane and alcohol be isomers? Let's see. Alkane CnH2n plus 2, alcohols CnH2n plus 2 and an O. So definitely cannot be isomers because isomers need to have the same molecular formula or chemical formula. Structures can be different, but formula needs to be same. And here there's a difference in the formula, right? So alkane and alcohol cannot be isomers. Moving on. Homemade vinegar is produced from wine. Wine is taken in a clean glass jar, shaken to aerate it. Then some water is added and it's kept undisturbed in dark place to undergo fermentation. After 3 to 4 weeks, vinegar would be ready to use. So wine changed to vinegar. Okay, So the functional group present in wine is alcohol. Functional group present in wine, beer, and even your whiskey and all, that is always alcohol. Vinegar is acetic acid, so it is an acid, carboxylic acid. Okay, which alcohol wine has? Ethanol, because that is the only drinkable alcohol that we have. Okay, so that is done. Based on the number of atoms getting added or removed when wine is converted to vinegar, name the type of reaction that has happened. See, only one additional oxygen has been added. So, and two hydrogens have been removed. So this is clearly oxidation. And since it's oxidation, any other chemical reagent that would be used for the same reaction, we know that there are two very commonly used oxidizing agents: alkaline KMnO4 and acidified K2Cr2O7. Okay, all right, moving on to the next question. Now, polythene is a plastic made from ethene, polyethylene. When ethene is subjected to high pressure and moderately high temperature, they react with each other to form large number of molecules 100 times bigger, forming the plastic. Which property of carbon atom is instrumental in formation of polythene? The tendency to form carbon-carbon bonds to form long chains or branches or cycles is called as catenation. Okay, so this is the property which is instrumental in formation of polythene. Moving on, ethanol is renewable biofuel because it is made from biomass. It's a clear colorless alcohol made from a variety of biomass material. Ethanol producers use food grains, crops, high starch, sugar. The most common ethanol production processes used yeast to ferment the starch and sugar in corn, sugarcane, and sugar beets. What is the chemical formula of ethanol? Very simple. There you go. What other compound is obtained as byproduct when ethanol is obtained from sugar? Okay, so the procedure that was used was ferment or fermentation, and whenever fermentation is carried out, carbon dioxide is released. Okay, so that would be the byproduct. What would be the product formed when ethanol undergoes complete combustion? Now this one is easy. You write ethanol, combine it with oxygen. Complete combustion means only carbon dioxide and water. Now let's just balance it. 2 carbon on the reactant side, 2 carbon on the product side now. 6 hydrogens on the reactant side, only 2 here, so let's put a 3 here. Oxygen, let's see, 4 plus 3, 7 here, 1 is already here, so let's put a 3 here. Okay, now this is the balanced chemical reaction. I think that's all for today, and thank you for watching. And if you have enjoyed this video and if it has helped you in any way, please like, share and subscribe my channel. Thank you.